Here's our vocabulary. All right, so what you got to know about a step function is there are open circles and closed circles. And you know, if you drop a vertical line, let's say we drop a vertical line, you say, well, Walls, Mr. Walls, that hits this graph in two spots. If you look closely at the blue arrow, the circle is closed, is shaded in. That means the function exists at this point. If we look at the green arrow, the circle is open. The function does not exist at this point. So our vertical line technically only hits this graph in one spot. Our next function is an absolute value function. And when you see two vertical lines, that means absolute value around a function. And absolute value is a distance a number is away from zero. So distance is always positive. You can't have negative distance. So we'll just get off into the general form and whether it points up or down. Here's an exponential function where x is an exponent and a and b are two numbers that are multiplied to one another. Now, if a and b is greater than 0, the graph is going to rise from left to right. And if a and b is less than 0, the graph is going to fall from left to right. And that is the nature of these functions. Here are rules and notes, and you can read, please pause and read these over, just like in all the video, to get an understanding before we move into actual practice. Okay, let's look at our first example. An ice skating facility rents its ring to school hockey teams by the hour. The graph gives the rental rates. The junior varsity players rented the rink for 3 hours and 15 minutes. How much did they pay? So it's rental by the hour, and which means if so for 1 hour, from 0 minutes to 60 minutes equals 1 hour. From 61 to 120 minutes equals 2 hours. From 121 to 180 minutes equals 3 hours. So on and so forth. And from 181 to 240 hours equals 4 hours. And so we know that each hour, once it hits the hour, you pay for another hour. So that's how time is calculated. So you can use all of that time or you can use some of that time. And we see that 3 hours and 15 minutes is 195 minutes. And that falls within the 4-hour time limit, and you will be charged the full 4 hours. So let's look at what the graph looks like. Okay, so now let's begin the graph of our points. So what you want to do, if you're not sure, time usually always goes on X. And then your other variable, whatever it is, let's call it costs in this case. But since we didn't have any points, we can still plot what we have. So we're going to call time 1 60 minutes, up to 60 minutes, time 2 up to 120, time 3 up to 180, and time 4 up to 240. And let me do this in another color so that you can see it. So there's a fee, so we're going to start here on X because it's not $0. There's some money, but we don't know what it is. So up to 1 hour is some money. Then at 61 minutes, so 60 minutes is not included, but at 61 minutes, you're into your second hour. So this is hour 2, hour 1, hour 3, and hour 4. At 120 minutes, which is 2 hours, it costs whatever. This point, because it's open, is not included. The open circle is not included in the solution set, but the closed circle is. And so this is what a step function basically looks like. It jumps, and that's why we call it a step function. It looks like a staircase almost. But one side of the function is not included, but the other side is. So once you drop your vertical line, you can see that it only hits the function in one spot and remains a function. Looking at option 2, graph the function. So I've given you an equation and a table of values. So you're going to put in 2, -2, -1, +1. -2 minus 1 is -3. The absolute value of -3 is +3. 2 times 3 is 6, plus 1 is 7. 2 times -1 minus 1 plus 1. -1 minus 1 is -2. The absolute value is +2. 2 times 2 is 4, plus 1 is 5. 0 minus 1 plus 1. -1, 2 plus 1 is 3. And then 2 times 1 minus 1 plus 1. 1 minus 1 is 0. 2 times 0 is 0, so you get 1. And then 2 times 2 minus 1 plus 1. 2 minus 1 is 1. 2 times 1 is 2, plus 1 is 3. And we can see this start to come back up again. So let's graph it. At -2, we're at 7. At -2, we're at 1, 2, 3, 4, 5, 6, 7. At -1, we were at 5. 1, 2, 3, 4, 5. At 0, we were at 3. At 1, we were at 1. And at 2, we were at 3 again. So we can see a nice sharp V. And if I would have kept going to the right, I would have made the V. And just because we graphed a part of it, don't think that the graph stops. The graph continues on indefinitely until we state or close the domain. Okay, let's look at our third example, an exponential function. To get an exponent on non-TI calculators, on non-TI 84 calculators, well, even on some TI 84 calculators, the button you're going to look for is y to the x. You can't see that in blue. Y to the x. That's how you put exponents in. If you do this on a TI calculator, let me show you what to do. There's a button at the top left that's light gray that says y equals. You're going to hit that. Then you're going to do 6 parentheses 1 divided by 2. You type these keys in just like I'm writing them. Then you hit caret x t theta n. It looks like a 0 with a line in the middle of it. This button, xt theta n, is right next to the green alpha button. This caret button is right over your division symbol. The next one is right next to your green alpha button. And then after that, you're going to hit the second button. And then hit the graph button, which is another one of those light gray buttons at the very top. It's on the far right. It's above your arrows. And if you hit, after you enter your function, I'm sorry, you got to hit enter right here. You got to hit enter. Once you hit enter, it'll try to graph the function. Let it graph. It's going to take a couple seconds to graph if you're using the TI. Then hit second graph to bring up the table. And then you can just get the values off the table. But if you're doing this by hand, remember, What the calculator will read this as is it will do exponents first. So it will flip the 2 because any negative exponent gets flipped upside down. So you have 2 squared, which equals 6 times 4, which is 24. Then you go 6, 1/2, -1 equals 6 times 2 to the first power, which is 6 times 2, which is 12. And then 6 times 1/2 to the 0 power, which equals 6 times anything to the 0 power is 1, which equals 6. And then 6 times 1 to the 1 power, 1/2, I'm sorry, 1/2 to the 1 power equals 6 times 1/2, which equals 3. Then you got 6 times 1/2 squared, which equals 6 times 1/4, which equals 6/4, which equals 1 2/4, which is 1 1/2, which is 1.5. All right, so according to orders of operation, exponents go before multiplication. So be careful and make sure you get the right answers if you calculate it by hand. So we won't be able to graph all of these points, but maybe I'll be able to graph -1 on the graph. So we got 12, 6, 3, 1 point. This again. -1 is 12. So let me look. -1 is right here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So let's put that up. 12. At 0, we were at, where were we at 0? 9. And then at 1, we were at 3. And at 2, we were at 1.5. Look at that thing go down. And at 3, we're at 0.75. Oh, I didn't do 3 on the graph. I'm just looking at my table of values. So if you can see, that comes down and kind of, but it never crosses 0. So it looks something like that. I didn't come through that 0, 9 point cleanly, but you just get the general nature of the graph. Okay, so those were our examples. Try the problems that are coming up on the next 3 slides. Remember, as always, pause, do the problem, do it on a piece of paper, try to figure it out, and then I will meet you at the end of this video for a recap. Okay, so let's look at our first problem here. So do the same thing, and you can do this on a TI-84. You can graph this function, but there's several more steps you have to go through, and I will go through that at another time. But basically, the absolute value of 2 times negative 2, in parentheses minus 1, becomes negative 4 minus 1, which is negative 5. And the absolute value of negative 5 is positive 5. 2 times negative 1 minus 1 equals 2 times negative 1 is negative 2 minus 1 is negative 3. And that's positive 3. 2 times 0 minus 1 minus 1, which is 1. 2 times 1 minus 1 equals 1. 2 times 2 minus 1 is 4 minus 1, which equals 3. Okay, so we got 5, 1, 5, 3, 1, 1, 3. So negative 2, we're at 5. I can look at my points. 0, 1, 1. So this means our V is in between 0 and 1. So at negative 2, we're at 1, 2, 3, 4, 5. Negative 1, we're at 1, 2, 3. I didn't put a 0 in there. 0 is probably at 1. And then positive, let's see, let me 1, 1. 2 was at 3. 1. So then we come down to some V and go back up. Okay, the absolute value cannot go below this line, x equals 0, so it must touch the line somewhere in between 1 and 1. We can solve for it, or we can use the computer to graph it, but that's what it looks like. Let's look at our second problem. 4 times 1/8 x. Okay, so 4 times 1/8 to the negative 2 becomes 4 times 8 squared. 64 times 4. Oh, this is going to be a big number. Equals 256. So this is 4 times 1/8 to the negative 1, which equals 4 times 8 to the first power, which is 32. 4 times 1/8 to the 0 power equals 4 times 1, because anything to the 0 power is 1, which equals 4. Exponential functions change very quickly. 4 times 1/8, which is 1/2, and then 4 times 1/8 squared equals 4 times 1/64. And how many times is 4 going to 64? 21 times? No. 124, 18 times. 18 times. Yep. 1/18. Okay, so to graph this, we got 0, 4, 1, 1/2, and then very large numbers. 0, 4, 1/2. So at 0, we're at 1, 2, 3, 4. At 1, we're at a half. At negative 1, we're at 32. So we're way off the screen. And at 2, we're at 1/16. So that is going to come down very quickly and never cross 0. is supposed to come very close but never touch 0. All right, looking at this problem, we can quickly identify this as an absolute value function will give you a v. So this one goes here. We're not sure about the exponential function, so what I would say is that you should probably graph them. But to cheat, our 3 is bigger than 1. So I would say this is going to go here. The number that's multiplying to the exponent is less than 1, so that one is going to go there. So make sure you graph them. Try to graph them. How we do that, let me show you how to put one in. To a TI calculator, I'm going to change it. The buttons you would hit is the Y equal, the top light gray button at the top left. Then you're going to see on the screen Y1, Y2, Y3, Y4, and so on and so forth. Then you hit 0.2 times 3, the caret button, which is above the division sign. Then once you hit that, you'll be taken up. Then you'll hit this button, which is next to the green alpha key, and then you hit enter. And then graph, which is at the far right. And this button is down at the bottom. The enter button is down at the bottom. And you'll see that the graph matches. So that is this video. Very rarely will I give you calculator tips, but I will work on that later. You should be able to do most of your things by hand, and then the calculator is just an aid. So when we get to more difficult things, or once we've had enough practice by hand, I will start to push you more onto how to use the calculator for skill. So most of the stuff we're going to do is be done by hand until we get to a certain point, and then we'll trust the calculator more, because I will trust that you will have watched a number of videos that will help you. All right, so thank you for watching. If you like what you saw, please subscribe, and there are more videos to come, and I will see you on the next video.